So we'll look at 44,
Yeah,
section, so this is section 4.4, number 44. It says f of x is equal to x to the 3/2 minus 4x to the negative 1/2 for x is greater than 0. And that obviously they have that domain restriction because you can't take the square root of a negative number. And we want to find the intervals on which it's concave up or concave down, so we know we need the second derivative set equal to 0 to get possible points of inflection. And then the critical points, which means that's where the first derivative equals 0. And since they just want to know local max or min, we can use the second derivative test to figure out whether they're max or min. Okay, so let's take our derivatives first. F prime of x is going to be equal to 3/2 x to the 3/2 minus 1, right? Which is 1/2. Minus, all right? Actually, it's going to become a plus, and this will be 1/2 times 4, so that's going to be 2x to the negative 3/2. Okay. And then the second derivative is going to be 3/4 x to the 1/2 minus 1, so that's going to be negative 1/2 plus, and then this is going to be the negative 3/2 is going to come in front, so that's actually going to be a minus, and the 2's will cancel, so it'll be minus 3x to the negative 3/2 minus 1, which is negative 5/2. Okay, and so yeah, these are kind of nasty.
Yeah.
I mean, finding that derivative's not so bad, but we need to find the critical numbers, so we'll set where this equals 0 and then also where this equals 0. So let's look at f prime of x. This is 3 over 2 square root to x plus 2 over, this is the square root of x cubed, which is x on the square root of x, right? And, okay, so your common denominator here is going to be 2x and then square root of x. So that means that you need to multiply this one by x over x, and you need to multiply this one by 2 over 2. Okay, and so then this gives you 3x plus 4 over 2x square root x. Okay, and you can set that equal to 0. This is going to equal 0. Obviously, when it'll be undefined when the denominator equals 0, which is at 0, but that's not in the domain, so we don't even have to worry about it. So we just need to look at where the numerator equals 0 to find the critical numbers. So 3x plus 4 equals 0. So x equals negative 4/3 is your critical number.
Why don't you plug in numbers greater than 0 on the bottom? You just
Well, this is the domain, and so this is telling you that you're not allowed, that the x is only defined from 0 to infinity, not including 0.
So, but why don't you plug in like 8 down here or something? You just do the numerator.
Okay, right now I'm just trying to find the critical numbers. I haven't plugged in to do the test yet.
Okay.
So right now I'm just finding the critical numbers, which occur either where the numerator equals 0 in a fraction or where the denominator equals 0, because that's where it's undefined. So yeah, in a minute I will. Although I don't actually have to on this because I'm only looking for whether it's a max or min, so I can use the second derivative test. But if I wanted to use the first derivative test and draw the number line, you're absolutely right. I would have to put it in both the top and the bottom, whatever number I choose. Okay. But actually, this makes me note something right away here. This is a critical number, but the domain is for x's greater than 0, so this is not in the domain. So that makes me think that there are no critical numbers. Okay, does that make sense?
Yeah.
Yeah. Okay. All right, now the second derivative, we can clean that up. It's 3 over 4 square root to x minus 3 over, okay, this is the square root of x to the 5th, which is actually x squared on x. So this is x squared on the square root of x. Does that make sense? So what we're missing on this one is an x squared, and on this one is a 4. So we're going to do x squared over x squared, and on this one we're missing a 4. So we come back here and we can say, right, this is going to be 3x squared minus 12 over 4x squared on the square root of x. Okay, and so we just need to see where the numerator equals 0. 3x squared minus 12 equals 0. So 3x squared is equal to 12. So x squared equals 4. So x equals plus or minus the square root of 4, which is plus or minus 2. But negative 2 is not in the domain, so here it's only x equals 2 is your only possible point of inflection. Okay, so you can draw your number line. When you draw your number line, it's different because this one it's 0 because it starts, and actually it's open parenthesis, but it's open parenthesis at 0, and then it goes in this direction, and then we can put 2 on there. We're going to look at the second derivative, values of the second derivative. So if we choose, for example, 1, and we plug it in here, we're going to get, so we'll test x equals 1, and we'll get 3 times 1 squared minus 12 over 4 times 1 squared on the square root of 1. So anyway, it's negative, right? So it's negative here. And then if you put a number greater than 2 in, like 3, you should see that that's going to be 9 times 3 is 27. It's going to be positive, and this is always positive. So, right? So that means that the original function f is concave down and then concave up. And so we have a point of inflection at x equals 2. So it's concave down from 0 to 2, and then it's concave up from 2 to infinity, and we have a point of inflection at 2 comma f at 2, whatever our original function was. You know, you can just plug that in to get the value in here, put 2 in there. It's going to be not pretty, some rational expression, or, you know, have some radicals in it and stuff.
So
now the increasing decrease, or appears to be, since there's no critical numbers, there's no max or min. So critical numbers, there are no max or min. And if you just look at f prime, we got 3x plus 4 over 2x on the square root of x. That's always positive, right? So that means that the function is always doing what? Good, increasing. So you can check your work with your calculator. If you come in here and go to the y equals and clear this out, and so it was x, you always want to put your exponents in parentheses, so the 3 halves, and then minus 4x to the negative 1/2. If you graph that, you can see, and you can almost, this window's strange. This is I had a trig window on here. If I do zoom 4, maybe it might be a nice one. You might actually even be able to see that the change in concavity happening at 2, which appears to be 0 as well. Let's see if we put 2 in here. Yeah, you get a 0. And you can kind of see how it's concave down. It's, you know, it's not always very obvious on the on these, but, and you can see that it's always increasing. Okay. Right. Did you want to try?
Yeah. Could you do 36 too?